Radio Waymo Breakfast.
Live from the New Scientist Labs, Janine Young, newscientist.com.
Joining us from Melbourne City today, it is Janine Young. Good morning, Janine.
Good morning, my friend. How are you?
Good. First up, the topics today, we're covering the environment. A couple of angles. We're going with the ocean and the forests. What's the latest that's going on, well, with water in general?
Water is a massive, massive issue of concern. There's been reports that have been showing for quite a long time that a large number of people, I think it's between 2 and 3, by 2026, I think it is, are going to be living in water-stressed areas. A lot of people are drawing water out of the water table, and that has issues for salinity, that's the word I'm looking for. Massive, massive problems. So a lot of countries, and Australia included, is turning to desalination for its drinking water. Now, this sounds like it's a fantastic panacea for all our problems because you take seawater and you produce fresh drinking water from it. There are some problems. The brine that gets produced out the other end, the Wonthaggi plant, which is down the southern part of Victoria, is the one that's going to be the next to come online, and there's a big, big, big fuss about what's going to happen to the brine. Now, I'm told that the currents should be able to take that brine out to sea and that it shouldn't be an issue.
Yeah.
A lot of people are very concerned about it, but the biggest issue is the amount of energy that it sucks up. It's equivalent to produce 150 billion litres of water a year of 20 offshore wind farms, and that's about 900 megalitres. Oh, look, it's a massive, megawatts I think it is, massive amount of power that's required to drive each desalination plant. So not surprisingly, there's a very large push on to try and increase the efficiency and reduce the amount of energy that these desal plants are using. So it works on the princess process, I'm not doing very well today, of something called reverse osmosis. What you're trying to do is force salt water through a membrane, and you're trying to block the salt out and let the fresh water through. It requires a vast amount of energy, as we've said. So some people are looking at it going, well, why can't we just use the process of sucking fresh water out of salt water by using a more concentrated solution out the other end? So it's actually using the fact that water will travel from a more dilute solution to, having a bad morning, concentrated solution to a more dilute one, because what it's trying to do is even things out. So you might think that by taking it from salt water into a more concentrated solution, you're actually just creating the same problem. You've still got to get water out of it. That's true, but it depends on the particular process that you're using. One draw solution, you can heat it after you've done the reverse osmosis process and drive off the ammonium bicarbonate, and you're left with just fresh water. This isn't so bad, and it doesn't use very much energy if you have access to, say, waste heat from a power station.
Right.
Excellent. Uses about 20% of what's going on at the moment. Sounds brilliant. But if you don't have a handy power station lying beside you, you don't really have that as an option, and therefore you've still got to use energy to get the fresh water out of the draw solution. Others are concentrating on changing the way the membranes are put together. They're using little tubules to make it a slightly more efficient process. Others are changing the salts that are involved. The whole idea is trying to reduce the energy usage that's required. There is a working plant of a particular process that uses a large pore membrane with a different type of salt, so you don't have to use as much energy to push the water through once you've done the initial separation. It's working in Oman and in Gibraltar, so there is a process that does work, but on the larger scale, it's not being used in too many places just yet.
It sounds similar to the problems that companies are having with coming up with a hydrogen car, and that it takes so much energy to make the hydrogen in the first place. So you do want like some kind of green result at the end of it, but in order to get the green results, it's energy intensive.
And if you take this as a life cycle analysis, which a lot of companies and a lot of different certification organisations do, then it may not be as good as it's been purported to be in the first place. It depends on whether or not it evens out by the hydrogen actually not producing as many emissions. Life cycle analysis is the kind of thing that does your head in, as far as I can tell.
Hey, next up, Janine, tropical forests all around the world are being hit by a double whammy.
Yeah, this one's very concerning. Everybody knows about deforestation and knows about climate change. What happens potentially when the two are going to hit different areas? using an analysis out to 2098 and working out what will happen to various rainforests and other really important areas across the planet, up to 82% of the tropical rainforest could be damaged by climate change and local destruction, so deforestation and the like, in that time. And unfortunately, there's no consistent patterns as to how it's going to hit them. South America, for example, climate change is going to hit the northeast harder, but deforestation is going to hit the southeast, whereas in the Amazon, it's both.
Yeah.
Great.
Yeah.
So they're thinking that knowing these sorts of things means that we might be able to work out, for example, which ones are going to be affected by, say, more deforestation than climate change, and set them up as protection areas. It could actually be a really useful way to work out what to save and what you can't save. However, there's the option that some people are going to look at this in a slightly more perverse sense and kind of go, well, it's doomed by climate change, let's just log it anyway. There are people who think like that, and you never know how they're going to react to statistics such as these.
Yeah. So let's not put that out there too much, eh?
Let's just think a little more seriously about the resources that we're taking out of the earth. I think that's probably the way to deal with it. And let's reduce our impacts by climate change.
All right. Well,
seems very straightforward to me.
Finally, a completely different topic. There's a study that's come out recently saying that early puberty in girls has doubled in a decade.
This is actually very concerning, and it does have very serious ramifications. A study of 1,200 girls in America across 3 cities was looking at whether or not they had any signs of puberty. So in this case, they were looking at things like breast development at very early ages, and they found that the proportion of girls, 10% in this case, that had breast development and the like, is double what it was in 1997. So it was 5.4 then, it's 10 now. And that is a bit concerning because 7 is so very, very young, and it has implications for later on in life. But the younger you are when you hit puberty, the more likely you are to experience depression, breast cancer, substance abuse, early pregnancy, even things like body image issues. It has serious ramifications as to when you hit puberty. They think that this may have something to do with increased nutrition. That's been happening for a very long time. In the 1700s, girls would hit puberty around 17, whereas it came down to 13. Apparently it's dropping even earlier now. They know that black girls have been having earlier periods in puberty for a very long time. White girls are now coming down to that kind of level as well. They think it may be to do with the increased proportion of overweight and obese girls in the population now, but it could also be chemicals that mimic things like estrogen. It could be, even soy milk. It's not necessarily anything that's artificial. They just don't know what's causing it at this point.
Chickens have been blamed for years. Can we put chickens on that list?
Yes, although apparently the proportion of hormones in chickens these days has gone down dramatically, as has antibiotic use. But I would imagine they're still there to some extent.
Janine Young from New Scientist, thanks very much.
You're welcome.
And those stories you'll find in the New Scientist magazine, which comes out next week. Also check out the website as well, New Scientist.